Multiplication properties of exponents. Remember that any number in the form x raised to the power of n is called a power. This is called a power. So, our example is 5 to the third power. The exponent, that little arrow is pointing to the exponent, 3. The exponent tells you how many times you're going to repeat the factor or the base. So 5 to the third power can be expanded to 5 times 5 times 5. We write it as an exponent, but it actually equals 25 because 5 times 5 is 25 times 5 more is 125. Now there are several properties that follow exponent rules. One of them is the product of powers. To multiply powers with the same base, you just add the exponents. For example, I have d to the third times d to the fifth. These powers both have a base of d, so that allows me to add the exponents. We'll write it as d to the 3 plus 5, which is the same thing as d to the power of 8. So I have two examples down here. The first one should be pretty simple. 4 to the third power. So I have a power, power, power. All of these have the same base. The base is 4. So when I multiply and the base is the same, I do what? Yes, add the exponents. 3 plus 6 plus 2, which means this actually equals 4 to the 11th power. Example 2 is a little bit different because the base in these powers are actually the x's. The 4, the 2, and the 3 are actually coefficients. We have to multiply the coefficients. 4 times 2 times 3, and then I can use that rule about when the base is the same, you add the exponents. X to the 3 plus 5 plus 1. Remember, when there's no exponent there, that's still to the power of 1. So 4 times 2 is 8, times 3 is 24. 3 plus 5 plus 1 is x to the 9th. Let's see what else we can learn about this. I think we have a rule called the power of a power. The power of a power. So p cubed raised to the 4th power. Well, when I'm trying to find the power of a power, I actually multiply the exponents. I multiply the exponents. Let's see if that makes sense. This is a typo here. So p cubed raised to the 4th power is the same thing as p cubed times p cubed times p cubed times p cubed, which, using the rule that we just learned, when the base is the same, I add the exponents, becomes p to the 12th. However, when I take a power and raise it to a power, I can actually just multiply the exponents. 3 times 4 is 12. So it doesn't matter how I get to it, but I will get the same answer. So let's look at example number 3. Let's see. 5 squared raised to the 4th power is the same thing as 5 to the 2 times 4 is 8. Let's expand this and check. 5 squared times 5 squared times 5 squared times 5 squared. The base is the same, so I can add the exponents. 2, 4, 6, 8. Oh, look at that. I get the same answer. So for this last one, y squared raised to the power of 4. 2 times 4 is 8. We also have what's called the power of a product. To find the power of a product, you need to of each factor and multiply. You have to find the power of each factor. So it's essentially the same thing as kind of distributing the power through. That's kind of how I think about it. So this 3 is going to be distributed to every single term. It's going to be distributed here, and here, and here. So it's the same thing as saying negative 3 to the third power. It's the same thing as saying x squared raised to the third power, and y raised to the third power. Negative 3 to the third power is the same thing as negative 3 times negative 3 times negative 3, which is negative 27. X squared to the third power is the same thing as x squared times x squared times x squared, which is the same thing as 2 times 3, or x to the 6th. And then y times y times y. Remember, these have 1's there. Same thing as y to the third power. So we have one example, I think, for this, possibly two. So let's look at this first one. I'm going to distribute this power. Remember, I'm going to distribute it to every term using multiplication. So 2 to the third power, x to the second power, cubed, y to the third power, cubed, and then I have 4 squared raised to the third power, x to the third, and y to the third. So 2 to the third power is 8, x to the 2 times 3 is 6, y to the 3 times 3 is 9, times 4 squared is 16 to the third power. I hope someone brought a calculator because I did not. X to the third, y to the third. All right, so let's look at our x's and our y's first of all. So because the bases are the same and I'm multiplying, I can rewrite this as x to the 6 plus 3. The y's are the same and I'm multiplying, so I can rewrite that as y to the 9 plus 3. I have to figure out what 8 times 16 to the third power is. So the first thing that I'm going to do in my calculator is take 16 to the third power. That's 4,096, and then I'm going to multiply that by 8. So I have 32,768 x to the 9th, y to the 12th. Okay. The last one, let's try this one. I have a negative. 2 to the third power is 8. A to the 2 times 3 is a to the 6th. B to the 3 times 3 is b to the 9th. Times, let's see, 5 squared is 25. A squared times 2 is a to the 4th. Negative 2 to the third, let's see, that's negative 2 times negative 2 times negative 2, which is negative 8. B squared to the third is b to the 6th. So then I can multiply this negative times 8 makes that a negative 8. A to the 6th, b to the 9th, times 25, a to the 4th, times a negative 8, b to the 6th. 8 times 8 is 64. A negative times a negative is a positive. 64 times 25 equals 1,600. So I've taken care of the constants first. I took care of that, that, and that. Let's see, a to the 6th plus a to the 4th becomes a to the 10th. B to the 9th plus b to the 6th becomes b to the 15th. And that's it. There you have it. So your assignment is actually homework, page 394 from your textbook. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I will let you take away 2 of your choice.